Hello and welcome to Sean White's Solar and Energy Storage Podcast. The title of this podcast is NEC, that's the National Electrical Code, and Energy Storage Systems, that's ESS, including Article 706, Parts 1 and 2. And that's right, Article 706 is Energy Storage Systems in the National Electrical Code. In this podcast, we go over ESS and the NEC, the 2020, the 2017, and the 2014 NEC, with Article 706, Energy Storage Systems, Article 710, Standalone Systems, Article 712, DC Microgrids, 690 is PV. We're going to talk about NABCEP. We're going to cover a little bit about the 1897, that's the first NEC, the 1897 NEC. We're going to discuss the 1984 NEC, that was the first one to have solar in it. We're going to cover some statistics that are interesting. Then we're going to go over NEC Chapters 1 through 4, which covers everything. Then we're going to go over the more specific areas of Chapters 5, Chapter 6, Chapter 7. We're going to talk about Article 705, Interconnected Power Production Sources, Chapter 8, Communication, Chapter 9, Tables. Then we're going to talk about NFPA, that's the National Fire Protection Association 855, standard for the installation of energy storage systems. We're going to complain about the problems with not being able to have the 2020 NEC in PDF form. Then there's Article 480, that's storage batteries, NECA, UL 1973, UL 1989, UL 9540, and UL 2436. Then there's flywheels, inverters, converters, gravity energy storage systems, uninterruptible power supplies, flow batteries, the AHJ, that's the authority having jurisdiction, the qualified person. You're qualified now for taking this course. Then we're going to go through the details of sections 706.2 through 706.16. That means we're going to cover parts 1 and 2 of Article 706, Energy Storage Systems. And that means part 1 of Article 706 is general, and part 2 is disconnecting means. To learn more about energy storage, go to solarsean.com and on with the information. Good day, ladies and gentlemen. Now we're going to talk about the NEC, the National Electrical Code. I've been studying the NEC for quite a while. I have a book that's called PV and the NEC. And so let's just go back and talk a little bit of history about the NEC and where energy storage fits into it. Up until the 2014 NEC, there was more information on energy storage in Article 690 photovoltaic systems than there was in the whole entire rest of the NEC. The NEC comes out every 3 years with a new version that gets adopted at different times. So after the 2014 NEC came 2014 plus 3 is 2017. So the 2017 NEC made some big changes as far as organization goes, and they took the energy storage away from Article 690, and they made a couple of different articles, some new ones. There was Article 706, Energy Storage Systems, Article 710, Standalone Systems, and Article 712, DC Microgrids. And pretty much most of that was taken straight out of Article 690, which kind of makes sense. So when I wrote the book, PV and the NEC, along with my friend Bill Brooks, who does a lot of NEC code writing, he's on the NEC Code Making Panel 4, a lot of times when we're talking about PV, we're covering the exact same topics which we would cover when we're hooking up an energy storage system, such as hooking up an interactive inverter to the grid. Whether that interactive inverter is coming from PV, from wind, or from energy storage, it has to follow the same rules. So if you've taken some of my PV classes, you might have covered a lot of this stuff. So I'm going to try to talk about the National Electrical Code here as it pertains to energy storage systems on a level that most people can understand. So the second edition of PV and the NEC, based on the 2020 National Electrical Code, which doesn't get adopted to half the places where people are installing energy storage systems until 2023, and that's when they also come out with the 2023 National Electrical Code. So there's different states that adopt the NEC at different times, which we're going to take a look at. I'm a NABCEP certified PV professional, but that exam that I took from NABCEP covers energy storage systems in good detail. So I took an exam that covered all the material that we're going to talk about from NABCEP. However, there have been rumors that NABCEP is going to do an energy storage certification. So we will see and we will be ready. Okay, we can tell that renewable energy is taking over, and the cover of the 2020 NEC, a yellow dwarf star on the cover. That yellow dwarf star, we like to call it the sun. Our sun is about 4.3 billion years old, and we've got about another 7 billion to go. Then after that, we're on our own. I think we've got a lot of time to figure out the technology to get out of here in 7 billion years. Do you know how long 7 billion years is? Okay, 3 years before the 2020 NEC was the 2017 NEC, and we had PV right on the cover. Kind of cool. The first Article 690, that's on photovoltaic systems, which also covered batteries, and that was in the 1984 National Electrical Code. It was a very small book compared to the size of the NEC right now. So Article 690 didn't go as deep as it does now. It's still produced in Quincy, Massachusetts. Massachusetts is the only place that adopts the NEC on day one. So on January 1st, 2020, the NEC was adopted in Massachusetts, and nowhere else was it used. The first NEC is the 1897 NEC. One time I was taking a plane trip and I made a presentation on the 1897 NEC. So if you ever need to know what was going on back in 1897 for some NEC history, let me know. We can do a presentation on that. Again, PV in the NEC does cover energy storage. In fact, perhaps since energy storage is getting so big, because of all the renewable energy on the grid, the third edition might be called PV Energy Storage Systems in the NEC. I mean, it's in there. We cover it. We could have already called it that. So where do you get the NEC? There's ways to get it for free. There's ways to pay for it. And of course, you can get a hard copy of the NEC. So if you want to get a copy of the NEC for free, that's a PDF version, one thing that you can do is just do an internet search, and from archive.org, they're saying that if there is a law, it's a legally binding document, you can't keep it away from the people through a paywall, and so they offer a downloadable copy of the National Electrical Code. They don't always have the most recent one, however. Another thing, too, is NFPA, that's the National Fire Protection Association. NFPA will let you see the NEC for free on their website. It's a little bit hard to navigate and to search, but they'll let you do it. And also, NFPA 70 is called the National Electrical Code. And if you want, you can check to see when they get the 2020 NEC or even the 2023 National Electrical Code. They're saying that since it is the law in Alabama, they have to give it to you for free. So as we were saying, Massachusetts adopts it first, and it gets kind of funny when they're trying to interpret the NEC and they don't really know how to do it. California, the most populous state, is exactly one cycle behind in adopting the NEC. So the 2014 NEC was adopted in January 1st, 2017. 2017 NEC was adopted January 1st, 2020. The 2020 NEC adopted in California in January 1st, 2023. And let's say that most of the renewable energy in the country goes into California. Sometimes it's even been most of the renewable energy in the country has gone into California. It does depend on the year and what's going on. California was kind of early going into renewable energy. In fact, if we went far enough back in time into the 80s, you might say that 90% of the solar in the world went into California when they were developing the Carrizo Plains with Arco Solar. So let's even talk about how forward-thinking the people that write the NEC have to be. So in 2020, I was on these committees, and we were coming up with information that's going to be in the 2023 NEC that will not get adopted in most places where renewable energy is installed until 2026. So that means 6 years later. And then let's add another 3 years to that because we're going to be using it for 3 years until they adopt the 2026 National Electrical Code. So this 6 could actually even be a 9 because they adopt it 6 years later and then they use it for 3 years. So you have to know what's going to happen 9 years in the future. A lot of this stuff that we're writing gets really confusing because we're writing rules for things that have not been invented yet. And we don't want to stifle innovation, so we have to leave the NEC open to new things that we don't even know what they are. Isn't that crazy? So solar is in a lot of ways related to energy storage because as you get more solar on the grid, you have to figure out where to put that solar during the daytime if you've used up all that solar energy. So you need energy storage. So as of Q3 2019, California has installed 26 gigawatts. That's 26,000 megawatts. And the number 2 state for cumulative solar is North Carolina, 5.6 gigawatts. Kind of just gives you an idea of what's been going on and where most of this solar has gone, which also translates pretty well to energy storage. I always thought this was interesting too, is Montana, they were skipping a version of the code. So they were adopting once every 6 years. Some people told me it was just because they didn't want to write a new test for their electricians. Hey, and it also saves money. And maybe because it gets so cold in Montana in the winter that they just burn that extra version of the NEC just to stay warm. Okay, now how the National Electrical Code is organized. So there's all different chapters. And chapters 1 through 4 are general rules for all installations, and this includes energy storage. And so chapter 1, it's general. There's things in there like definitions. Chapter 2, wiring and protection. We have grounding in there and services, a lot of different things. Chapter 3, we have wiring methods and materials. That's where we go for wire sizing and different things. And then we have chapter 4, which is equipment for general use. Then chapters 5, 6, and 7. And these are things that modify chapters 1 through 4. So that means if we have something that's a little bit different in chapter 5, 6, or 7 that was different from 1, 2, 3, or 4, then we go with chapters 5 through 7 because it modifies it. It can change it a little bit. So we have chapter 5, special occupancies. That could be if you're putting energy storage into a barn or at a gas station. There might be special rules because you don't want your horse bumping into some pipe, or you don't want your gas station blowing up with the spark. Then we have chapter 6. We find things there for special equipment, such as swimming pools and PV systems. And PV systems, by the way, is in Article 690, type of special equipment. But then we're going to find our Chapter 7 energy storage systems in Article 706. So just think of that too. Chapter 7 has different articles in it, and articles are 3 digits. In Article 706, in Chapter 7, is energy storage systems. We're also going to go over Article 705, that's interconnected power production systems. So that's how you're going to connect your energy storage system to the grid. Article 710, which is standalone systems, and Article 712, which is DC Microgrids. AC microgrids are already covered in Article 705, interconnected power production sources. In fact, there's talk about getting rid of Article 712 DC microgrids and just throwing it into Article 705 interconnected power production sources. And now Chapter 8, which is communications, which is getting more important with all the monitoring going on with solar systems. Then Chapter 9, which includes tables, and we can use tables for things like voltage drop calculations. That's Chapter 9, Table 8, and other tables that tell us how many wires will fit in a conduit, which are tables 1, 4, and 5. So when there's no pandemic going on, which actually happens once in a while throughout different centuries, then we can have meetings that are in person. The National Renewable Energy Lab. That is about $1 billion lab. I know because I paid for it as a taxpayer. And we would typically go and have meetings where it's in the middle of the country. People from the east, people from the west can all meet. It's just kind of neat to go here. And a lot of people are paid to go by their companies, but I go there as an independent. And we come up with proposals for what's going to be in the National Electrical Code. And I typically sign up for all the committees that have anything to do with energy storage. I also participate in some of the PV committees, but I like to focus on energy storage because it's the new thing. Golden, Colorado, right near Denver, beautiful place. So the NFPA that publishes the National Electrical Code also publishes many other codes and standards. So NFPA 855, and that's the standard for the installation of stationary energy storage systems. And to my knowledge, I'm pretty sure that this standard has never been adopted on the state level for anything. It could be, but it hasn't. But the NEC is adopted in every state. So this has a lot of good, interesting information. Sometimes it actually contradicts the NEC a little bit if you get into the details. That's one of the things that we're working on with the different committees, is trying to make it fit together a little bit better. So why have a standard if it's not adopted? Well, when you're building an energy storage system, you might want to have some good ideas. And you could have, say, an insurance company that requires that you install your energy storage system to comply with this standard in order to be insured at a better rate. So you will see different people and places using NFPA 855, although it's just not something that the government is enforcing. The 2020 NEC, you can't get an electronic version that works offline. I was very upset when I found this out. It made my life a lot more difficult. Tried working with screenshots for when I was on airplanes, but by now I've gotten a little bit used to it. In the 2017 version of the National Electrical Code, they had a PDF version. The handbook has extra explanations and extra pictures, and I can index it, which is something that you can't do anymore because they got rid of the PDF version. I could do Control F and search for anything I want. It was so nice. So I really liked it, but they got difficult. And now NFPA no longer does this. I know a lot of people that have complained to NFPA, and I suggest that you do too. Tell them to bring back the PDF NEC, their inferior version of the NEC that only works when you are online, and it doesn't work as good, and you have to sign in at different times, and they don't have all those extra handbook explanations, and the search function really stinks. And so isn't it interesting that the NFPA is going backwards as far as technology goes? It's probably because someone is just greedy. And also, by the way, too, is NFPA doesn't always get it right, so you have to read it carefully. 706, energy storage systems. So we are not going to apply Article 706 for energy storage systems smaller than 1 kilowatt hour. And they're also calling this 3.6 megajoules. We don't really use megajoules in the field, but a joule is power times time, which is energy. So a joule is a watt times a second. And there's 3.6 million watt seconds in 1 kilowatt hour. So it applies for standalone or interactive systems. So standalone means off-grid, interactive means grid connected, or it could be both. Then informational note number 2, there's a lot of confusion and it's not straightforward because there's Article 480, which is called storage batteries, and Article 706, which is energy storage systems. Article 706 is modern, Article 480 is kind of old-fashioned, and there's not a clear defining line to tell you which article to use. However, most experts say use Article 706. If you did use 480, you might be able to get away with more. Article 480 might be used more often for things like lead-acid batteries, and Article 706 might be more often used for things like lithium batteries, which have to have battery management systems built into them. Some different standards where we can look up different things about energy storage systems. And remember that these standards are not necessarily adopted by every state. And it's interesting to note that they didn't even put NFPA 855, the standard for energy storage systems. So informational notes are not rules. They're just good ideas. So they're giving you some good ideas, some different standards that you might want to look at. NFPA 111, Standard on Stored Electrical Energy Emergency and Standby Systems. NECA, that's the National Electrical Contractors Association, recommended practice for installing energy storage systems. And then UL 810A, electrochemical capacitors. And capacitors are a different way to store energy. There's UL 1973, standard for batteries used in stationary, vehicle auxiliary power, and light electric rail applications. So most of our energy storage systems are UL 1973 listed. Good thing to know. You can go see that on your LG Chem battery or your Powerwall. You'll see that it's UL 1973 listed. Then there's UL 1989, standard for standby batteries. UL 9540, standard for safety for energy storage systems and equipment. And UL 2436, spill containment for stationary lead-acid battery systems. Yep, you don't want to spill any of that acid on you. Then we have Article 706 definitions. And so pretty much most of the articles in the National Electrical Code have a .2 article. So we'll see something like 706 is the article and .2 makes it section. So we could say Section 706.2, definitions. However, there's a lot of definitions in Article 100 definitions. So you might see most of your definitions that you're looking for in Article 100. Perhaps a good place to go study things. We can see DC to DC converter, electric vehicle, lots of different definitions that we might end up using for an energy storage system. We can see fuel cells there, way to store energy. Inverter, inverter input, inverter output. A lot of these things we will be using for an energy storage system. Island mode, very relevant for energy storage systems. That means you're islanding. That means you're an island of power. That means you can work when the grid is not there. Power production equipment, lots of important things. So go ahead, take a look yourself and see all the interesting things that you can find. Now let's go back where we left off. In Article 706, Energy Storage Systems, we've got something here called a diversion charge controller. So let's talk about what that is. Let's say that your battery is fully charged, or you want to slow down the charge to your battery. Maybe what you can do is send some of that extra power somewhere else. One of the places you can send that extra power that you're not using to charge your batteries is the grid. But other examples of diversion charge controllers would be a heating element in a hot water tank. So let's say you live off grid, your batteries don't need as much as the sun has to offer, so you can put that extra sunshine into your hot water tank. And another popular diversion charge controller would be a water pump. So you got more sunshine than your batteries can handle, pump some water. Energy storage systems, ESS. So let's see what it says about an energy storage system definition. One or more components assembled together capable of storing energy and providing electrical energy into the premises wiring system or an electric power production and distribution network. So that means it can include the inverter and things like that. And I expect in future versions of the NEC, we're going to further define that, because that is a good question. Does an energy storage system include the inverter? We could probably imply that it does, as long as there's nothing else there between the energy storage system and the inverter, such as a PV system, because that would be a different system. But if that inverter was only there because of that battery, then I would say that that inverter is part of the energy storage system. And that's something that will get further defined in future versions of the NEC. So informational note, so it's just kind of giving us some good information. And it says that the energy storage systems can include, but are not limited to, batteries, capacitors, kinetic energy devices. So kinetic energy device is something that holds energy with motion, such as a flywheel or compressed air. I might also include gravity energy storage there. Energy storage systems can include inverters or converters, such as a DC to DC converter, to change voltage levels or to make a change between AC or DC. And that's pretty much what an inverter is. An inverter is DC to AC, but when you're charging a battery, you're going to go backwards. You're going to be a charger going AC to DC a lot of the time. Now let's read extra informational note about energy storage systems. These systems differ from other storage systems, such as a UPS system, so that's uninterruptible power supply is UPS in the National Electrical Code, which is a power supply used to provide alternating current power to a load for some period of time in the event of a power failure. So we're just differentiating our energy storage system from a UPS. But when you look at that too, there's going to be some times where there's just a lot of crossover and you're doing both at the same time. So let's see what the National Electrical Code says a flow battery is. A flow battery is an energy storage component similar to a fuel cell that stores its active materials in the form of two electrolytes external to the reactor interface. So that means we're going to have two different tanks of electrolytes with pumps. When in use, the electrolytes are transferred between reactor and storage tanks. The reactor interface is going to determine the power. The size of the tank is going to determine energy. Two commonly available flow battery technologies are zinc bromine and vanadium redox. And it seems that vanadium redox is the more popular one now. So that would mean zinc bromine is kind of going out of style, if you ask some people. Except for the people that are selling zinc bromine. Of course, they're going to tell you that it's not going out of style at all. Sometimes they call this pumped electrolyte energy storage systems. So the flow battery, this is also very much compared to a fuel cell. We'll see that towards the end of Article 706. the inverter utilization output circuit. These are the conductors between the multi-mode or standalone inverter and the utilization equipment, whatever's using the energy storage. And so this would be for something that can work multi-mode or standalone. So that would be something that could work when the grid is down. Standalone just means no grid at all. Multi-mode means it can work with the grid or without the grid. And once again, too, these are the 706.2 definitions, but there's many more definitions that are relevant in Article 100 definitions. In fact, when something becomes more mainstream, it gets moved to Article 100. So perhaps in the next version of the National Electrical Code, something such as ESS energy storage system will be moved to Article 100. And then it applies to the whole code. So qualified personnel, things are supposed to be installed by qualified people. And it's up to what's called the AHJ. And let's talk about the AHJ. What that means is authority having jurisdiction. Typically it's the building department, but it's just some authority that has jurisdiction over what you're doing. It could be the utility or possibly even an insurance company. But usually when people say the AHJ, they mean the building department. That would be city or county, and it's up to them to decide what qualified is. AHJ might say that you have to be an electrician, or in another one might say that you might have to be an electrician that took this course. In California, there's been a fight over whether solar contractors, that's somebody that has a solar contractor's license, can install an energy storage system, or if it has to be an electrical contractor. Fortunately, I have both of those licenses. So 706.4 is telling us how something should be marked, how the energy storage system should be marked. And a lot of times when you buy the energy storage system, this information will be written on that energy storage system before you install it. So we're looking at things like the manufacturer's name, the frequency, single phase or three phase, how powerful it is, the fault current, input and output current, the voltages, and if it works interactively, that means the utility interactive if it can feed the grid. So hopefully all this stuff is already written on your energy storage system. So energy storage systems shall be listed, and that brings us back up to where we were. And so a lot of times they are listed at UL 1973. 706.6, you can put multiple energy storage systems on a building or structure. Of course, why not? And so 706.7 says we need to maintain them in a proper and safe way. Informational note that they're trying to sell us something. So they're trying to sell us another NFPA thing. That's something that they publish and make a lot of money off of. And that would be NFPA 70B, which is recommended practice for electrical equipment maintenance. So what do you know? And I would say that most people installing solar systems don't go out and buy NFPA 70B. And then this is where it gets confusing for a lot of people, even that write the National Electrical Code. There's a controversy with Article 480. A lot of people writing Article 706 say that we should get rid of 480. In fact, that was the plan when they made all the big changes switching from 2014 to 2017 National Electrical Code. The plan was to get rid of 480, and then last minute, the 480 people kept it in there. They say that a lot of the political force behind Article 480 has to do with people putting up things like remote cell towers, so they're still using old-style storage batteries. Think about lead acid or nickel-based batteries. There are some contradictions in the National Electrical Code, and this is one of them. The fight over 480 versus Article 706. It is recommended by most in the solar industry that you use Article 706. There's some things in Article 480, which we'll look at a little bit, that will say you don't even need disconnects sometimes. Crazy. But hey, those people making those cell towers, they're trying to bring their costs down. And if it's on a cell tower, it's not like it's in your house or something. So I can sort of see where they're coming from. So now, what is the maximum voltage of an ESS? It would be the rated input and output voltages on the nameplate. So look on the label. It'll tell you what can come out of that thing. Remember, an energy storage system is not just a battery. It has the electronics that can control things like voltage and current. Okay, folks, and one more thing I want to reiterate here before we hit Part 2, disconnecting means for Article 706, is that if this is not your cup of tea, you are allowed to skip over the rest of me covering the National Electrical Code. It is important. It's the rules for installing these energy storage systems, and I'm trying not to get too advanced here. Okay, so now we're talking about disconnecting means. And so just like it says, it's the means for disconnecting something, for turning it off, for opening the circuits. Open means off with electricity. So for all ungrounded conductors, so that means wires that are not 0 volts to ground. So sometimes we have neutrals that we don't disconnect. That would be a white wire in the United States, a blue wire in different places besides the United States typically. Some countries, it might even be a black wire. But ungrounded conductors, those are the ones that have voltage to ground. So also we're not disconnecting the equipment grounding. That's usually a green or a bare wire. And so we need to open up these ungrounded conductors. This is pretty standard throughout the National Electrical Code. This is nothing new. Some special rules about the disconnecting means. You want it to be readily accessible. So that means you're not going to put it someplace where you can't get at it. If you wanted to look for the definition of readily accessible, that's when you can go to Article 100 of the National Electrical Code. And what do you know? Here we are at Article 100, Definitions of the National Electrical Code. Just to give you an idea, under Part 1, General, so that's not for high voltage things, accessible, readily, and then it says readily accessible. Capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite, or to take actions such as to use tools other than keys to climb over or under, to remove obstacles, or to resort to portable ladders and so forth. Then they have informational notes, and remember this, informational notes, they are just like that yellow sign when you're driving. It's recommendation and it's not officially enforceable. However, in AHJ, they can enforce whatever they want. So it says the use of keys is a common practice under controlled or supervised conditions and a common alternative to the ready access requirements under such supervised conditions as provided elsewhere in the NEC. So pretty much readily accessible means you can get at it quick, but you might have to use keys, but you can't have to use tools. So if you have to take off a screw, remove a solar module, or whatever, then that is not readily accessible. But if it's behind a locked door, that could be readily accessible. How what we're doing is you go to one place in the NEC and it always sends you to another place. So when you're in Article 706, it does not mean that other things don't apply. You can't just install an energy storage system by only looking at Article 706. You would have to look at the whole rest of the National Electrical Code, specifically Chapters 1 through 4. And Chapters 1, General, 2, Wiring and Protection, 3, Wiring Methods, 4, Equipment for General Use. And then we go back to our Chapter 7, Energy Storage Systems. Back at Disconnecting Means, we're talking readily accessible. So also this disconnecting means, or a lot of times we call it a disconnect or a disco, if you like 70s terminology. So just what we're saying here, and we're going to call this 706.15a2, is we want it to be in sight, but if it's not practical to put it in sight, put it as close as you can. Another thing is you need to have that disconnecting means be able to be locked in the open. Open with electricity means off. That's like open the circuit. We need it to be able to be locked in the off position. And the reason for that is if somebody's working on something and they're not right there, we don't want somebody else coming along and turning it on and electrocuting somebody. And then if you're doing something on a 1 or 2 family dwelling, the disconnecting means, or its remote control, so you can have a remote control for the disconnecting means, shall be located at a readily accessible location outside the building. So they need to be able to turn it off from the outside of the building. This has been a little bit controversial because if you're not going to use a remote control, that might mean that you're going to take all the energy storage systems wiring, bring it to a disconnect outside, then bring it back in the house. So when you turn it off from the outside, you're still going to have those energized conductors coming from the energy storage system to the outside. So you're going to still have hot wires coming through the house a longer distance than if you didn't do this at all. So having that remote control, or I should say remote actuation device, would be a little bit safer. Remote actuation device is sort of like the key to your car, or at least an old-fashioned car. These new ones are so fancy, they might even be electric, so you don't have a starter motor. But when you're turning that key and it turns on the starter motor, all that current is not going from your battery through your ignition and then back to the starter motor. What's happening is you have remote actuation. And if you're a mechanic, you might have known that as being called a solenoid. So you turn that key, there's a small amount of current, and then there's something else that remotely turns on the starter motor. You might also know about this solenoid too. If you're a car thief, you got to know about that too. Any car thieves in here? Raise your hand. Glad you're switching careers. Okay, now we're talking about our disconnecting means, notification, and marking, 706.15c. So what we're telling you here is each energy storage system disconnecting means shall indicate when it's on or off. So there's going to be a sign that says energy storage system disconnect, and we need to see that disconnect if it's on or off. So it can't just be some kind of button where you go click on, click off without seeing the position of something that's showing that, hey, that's on or off. One of the things that you notice about a lot of disconnects, when there's a handle that you pull down, pulling it down turns it off. Pushing it up turns it on. So I always think of gravity assists you in turning it off. So we need to have at the disconnecting means a sign that says what's the voltage of disconnecting means and available fault current, which you would get from the energy storage system manufacturer, an arc flash label, and a date the calculation was performed for that available fault current. A lot of this kind of goes back to having a DC energy storage system. So a lot of our energy storage systems are AC and might not have high available fault currents. So this would perhaps be changed in the next version of the NEC. If you're going to have a switch and when you turn something off, you still might have voltage on both sides of that switch, then you're going to want to see a sign that says, warning, electric shock hazard. Terminals on the line and load sides may be energized in the open, that means off, position. So for instance, you might see something like this on a DC coupled system where you're going to go from your DC energy storage system to some DC bus. Maybe you have PV connected to that DC bus and then off to an inverter. So if you turn off the energy storage system with that disconnect, there might still be some voltage at the battery and then some voltage on the other side of the DC bus, maybe coming from the PV system or back from the grid. Then you would need to have sign right there. So 706.15d, partitions between components, is just telling us that if we have an energy storage system that's going to have circuits going from it through a wall, floor, or ceiling, that you need to have a readily accessible disconnecting means within sight of the energy storage system. And also, these disconnecting means could be a fuse disconnecting means, or a circuit breaker is also a different type of a disconnecting means. Then we're going to look at 706.16, connection to energy sources, and then we're going to have A, B, C, D, E, and F. And that's going to bring us to the end of part 2, disconnecting means. So a disconnect that has multiple sources of power shall disconnect all energy sources when in the off position. That's 706.16a, source disconnect. 706.16b is identified interactive equipment. So interactive, remember that means grid tied. If you don't remember anything else, remember that an inverter that is interactive is something that's grid tied and will turn off when the grid goes down. Energy storage systems that operate in parallel with other AC sources, like that could be the grid, shall use inverters that are listed and identified as interactive. So remember, interactive does anti-islanding. So an interactive circuit cannot be an island of power. So remember that sign that we were already talking about where line and load may be energized in the open position? You would not put that on an interactive circuit because on an interactive circuit, when you turn it off, the inverter side has to automatically not make power very quickly. So you're not going to have any electricity on the inverter side of a disconnect of an interactive inverter because once you turn it off, it anti-islands. The reason for that is grid safety. Let's say that the grid went down. Your interactive inverter cannot feed the grid when the grid goes down. That could be a danger to people that are working on the power poles. That's called anti-islanding, where it can't become an island of power. So any grid tie inverter circuit has to be able to anti-island. Okay. 706.16c, loss of interactive system power. Upon loss of primary source of power, an energy storage system with a utility interactive inverter shall comply with 705.40. We're going to talk about 705 a little bit. And I'm trying not to get too deep here, but we don't want to just go through everything and skip the last part here now. Unbalanced interconnections. So sometimes you will have, say for instance, a 3-phase system on a commercial building because commercial buildings oftentimes are 3-phase. And if you were pumping too much power into one phase, you might throw something out of balance. So a lot of times you're going to have 3-phase inverters, but you could use 3 single-phase inverters. And it's possible to make things more balanced because sometimes your loads are out of balance And so if you put interactive circuits on loads, they cancel each other out. So it's possible to make things more balanced, but it's also possible to make things less balanced. Also, a lot of times when you see a big long list of things, there's going to be something that's other. And so if you're connecting to other energy sources, you go to Article 705. 705 is a big part of energy storage systems. That's interconnected power production sources. And then, last but not least, especially if you're all alone working off-grid, is for standalone operation, where the output of an energy storage system is capable operating in standalone mode. So that could be your backup system for when the grid goes down. Then the requirements of Article 710.15 apply. Article 710 is standalone systems. And there's some special requirements that we have that was also stolen from 690.10 in the 2014 National Electrical Code. Then they made their own very short article on standalone systems. So we are done with parts 1 and 2 of Article 706. I hope you took in all of this knowledge, or at least got familiar with some of the terminology and kind of have an idea of how the National Electrical Code works. Thanks for listening to Sean White's Solar and Energy Storage Podcast. To learn everything, go to solarsean.com.